Go. All right, chapter 5.6, the other four trig functions. So who's left? We got tangent, cotangent, secant, cosecant. I will tell you that the most important of the remaining four is tangent. And not surprisingly, right, when you learned in geometry your right triangle ratios, you learned SOHCAHTOA, right? Sine, cosine, which we've already learned, and TOA was for tangent. So let's go ahead and take a look at it. Here's what tangent looks like, right? We can actually take the tangent values off the unit circle and then unwrap them as well, and then plot the points. So what is tangent of 0? 0, right? What is tangent of pi 6?
That's the thing.
It's the thing.
The thing.
Tangent of pi 6. Oh, we need a unit circle quiz on Monday? No? Square root of 3/3, right? Remember? Yeah, let's not forget. Tangent of pi 6 is square root of 3/3. What's tangent of pi 4ths? 1. Good. What's tangent of pi thirds? Square root of 3, right? What's tangent of pi halves? It's D and E, right? Because it's some type of infinity. So what the tangent ratios do, they start out of the origin here, and the tangent ratios get really, really big, really, really fast. Because remember, you're measuring the vertical to the horizontal. And as you rotate up from 0 to pi halves, your vertical is getting bigger while your horizontal is getting smaller. So there's two ways to make a ratio bigger. You either make the numerator bigger, right? Or you make the denominator smaller. Well, both of those things are happening on the tangent ratio as we rotate. And they get so disproportionately large compared to each other, the y to the x, that it increases towards infinity. So remember, infinity on a graph manifests itself as a vertical asymptote, right? Because that's what forces the y values up. Now, if we work backwards, okay, into quadrant 4, rotating clockwise, what would tangent of negative pi 6 be? That's the same as cotangent of 11 pi 6. Negative square root of 3/3. What would tangent of negative pi 4ths be, which is the same as tangent of 7 pi 4ths? Negative 1, right? And what would tangent of negative pi thirds or tangent of 5 pi thirds be? Negative square root of 3. And what would be tangent of negative pi halves or tangent of 3 pi halves? Does not exist, okay? So we call this one cycle of tangent, right? One cycle of tangent. Just like sine and cosine had cycles, we call them periods, right? This is one period of tangent. Because what's going to happen from pi halves to 3 pi halves? Well, they're going to repeat themselves, okay? So if this is one cycle of tangent, because it repeats itself on the next interval the same way, what would the period of tangent be? How far is it, in other words, from negative pi halves to pi halves? One what? 1 pi, right? 1 pi. So what was the period of sine and cosine? 2 pi, right? But tangent and cotangent, for what it's worth, they repeat themselves twice as you go around the unit circle once. So they have a period of pi by default, okay? So if you want to sketch what the graph of tangent looks like, here's your new parent function. Parent function, we're going to sketch it together. We're going to call this f of x equals tangent of x, where x is the angle in radians, okay? X is the angle in radians. Let's give ourselves an x and y axis, x axis. We're going to sketch a couple of cycles. Here's what we're going to do. We're going to put down our critical values. We know it passes through 0, and then at pi halves, it has a vertical asymptote. This is what we're going to be counting by. We're going to count by half cycles instead of quarter cycles, okay? The period is pi, but we're going to count by 1/2 the period, which is pi halves. For sine and cosine, we counted by quarter cycles, right? Sahala and Chala. So here's what's going to happen. We're just going to alternate now every pi halves. We're going to go from an axis point, we'll call that axis point, to a vertical asymptote. And then at the next point, let's put we'll put one more down here. And then I'll go to the left, 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 left. Let's go ahead and label them first. What are we counting by? Pi halves, right? So 1 pi halves, this would be 2 pi halves, which is pi. And then we get 3 pi halves. And then we get 4 pi halves, which is 2 pi. And if we go to the left, -1 pi halves, -2 pi halves, -3 pi halves, so on and so forth. I'll add one more here since I have room, kind of. -4 pi halves is -2 pi. Now, here's what we do when we're going to sketch it. You remember how we set the table with Sahala Chala? For tangent, we set the table by alternating axis VA, AVA, AVA. So the next one is going to be an axis and then a vertical asymptote, and then an axis and a vertical asymptote. And we go back to the left. So from axis, we go vertical asymptote, and then axis and vertical asymptote, and then axis and vertical, so on and so forth. The period is pi. We count by half cycles, which is pi halves. And of course, I have a vertical asymptote at pi halves. Now that we set the table, all we got to do is eat, right? Here's how we eat. We draw something increasing, boom, and then it increases. So on the axis point, it is an inflection value. It does change the curvature there. It looks a lot like x cubed, doesn't it? Our parent function. The only difference is x cubed, as it goes up to infinity, it goes out left and right towards infinity, and it also goes horizontal at the origin. Tangent does not go horizontal at the origin. As tangent goes through the origin or any axis inflection value, it launches through at a 45-degree angle, okay? It launches through at a 45-degree angle. This is your parent function for tangent of x, okay? And on Monday, we'll look at some of the features, like what's the domain, what's the range, does it have any symmetry, et cetera, et cetera. But this is the only graph that I'm going to hold you accountable for out of this section, okay? And then we're gonna move through this sections really quickly. All right, what a fantastic day we had in here today. We got to meet a new parent function, and we got to watch a Zeus and Hank Aaron and baseball, and more importantly, we got to watch Danny Dorito. Y'all have a super duper awesome, wonderful weekend. Remember, if you're retesting Monday morning, I'll be here when the doors open.